Hey guys, so today I will be going over the test review for tomorrow's test. I'm going to have the calculator pulled up on the side here just so you can see whenever we are using the calculator for the change of base formula and getting answers that aren't whole numbers, you can see how we get those. So I'm going to start with the, obviously the first one, number 1, and we're solving the equation on these. As you can see, I'm going to be doing the left side, so the part that y'all will be doing for review will be all the even ones. So on this first one, it says ln of negative 2x plus 5 equals ln of 13. Now we're solving these equations, meaning when we're solving for x, and I know that with ln, my base is e. If your base is the same, then, and it says they equal each other, then this has to equal 13. So I'm going to take negative 2x plus 5 equal to 13 and solve that for x. So I'll subtract 5, negative 2x equals 8 divided by negative 2. And x equals negative 4. Then on the next one, it's the same type of problem. So we've got natural logs, which we know have that base of e, and then we have negative 2b and negative 3b minus 1. If we've got this equal sign here, then negative 2b has to equal negative 3b minus 1. So I'm going to solve for b. So I'll add 3b to this side, which just gives me b. And then on this side I just have negative 1, so b equals negative 1. Now in the next section, we're evaluating each expression, so we want to know what these would equal, and we can use the change of base formula if we need to. So whenever it says if needed, it just means that it's not like 3 and 27, where I know I can take 3 and cube it and get 27. So the left side are good examples because 5 and 7 have decimals in them. So whenever we're using the change of base, we're going to use base 10. So we're going to say that log of 2.7 and put that over log of 3. So now they have the same base, which is a base of 10. So I'm going to go into the calculator and I'm going to find log. So log, and since it already automatically puts that you need a base, we use base 10. 2.7. I'll do it again. Log base 10 of 3. So we get this decimal here, 0.9041. So 0.9041 is what that log would equal. Now let's do number 7, which also has a decimal. So this would be log 4.8. We're using base 10, so we don't need to write it. Over log 4. So we'll do the same thing again. We create our fraction first. Log base 10 of 4.8 over log base 10 of 4. Oops. And for this one we get 1.13152. I'm just going to write the whole thing since it didn't keep going too far. Now on number 9, we don't have a decimal, but I know 6 squared is 36, not 34. So we're not going to be able to find this log easily, so we'll use the change of base. So log of 34 over log of 6. Same thing again, calculator. Base 10, 34, base 10, 6. I'll get 1.981, which makes sense that it would be close to 2 because 6 squared is 36. So I needed something close to 2 but not quite 2, which gives me that 1.9. Now on the next section we are condensing into a single logarithm. So on number 11, I need to take this as a power and that as a power and make them multiply. So I have log base 4 of 3 to the 4th power plus log base 4 of 10 squared. And now I'm going to multiply those. So log base 4 to the 4th times 10 squared. And we can find out what that is. 3 to the 4th times 10 squared. So this is log base 4, 8100. It's a little hard to read. Alright, and then on number 13, now we've got these fractions in here. So I'm going to rewrite these. Instead of a fraction, I'm going to use a coefficient of 1/2. So it's the same thing. It's just something that makes a little more sense in my brain. Because now that coefficient goes as a power, and these will condense it to multiplication. So I have log base 3 of 11 plus log base 3 of the square root of 12. Remember, anything to the 1/2 power is a square root, plus log base 3 of the square root of 7. Log base 3 of 11 times the square root of 12 times the square root of 7, which is log base 3 of 11 square root 84, I think. What's 7 times 12? Yeah. And so we could find the prime factors and simplify that radical, but that's not what we're doing on this test. We're just finding our knowledge with logs, so we're going to leave it there. Now on this next section we are expanding. So whenever we're expanding, we want to make the log longer. We don't want it to be one single log anymore. We've got log 8 square root of 6 plus log 8 square root of 5 plus log 8 square root of 7. And so remember, those square roots are powers of 1/2, so I'm going to move that power to the front, which would be 1/2 log base 8 of 6 plus 1/2 log base 8 of 5 plus 1/2 log base 8 of 7. And from there, I don't see anything that can expand any further. Next one, this is a log base 10. We've got log of 3 squared plus log of 2 cubed. Those powers are going to move to the front as coefficients. 2 log 3 plus 3 log 2. Now the next one, rewrite each equation in exponential form. So we're just rewriting first, last, and middle. So we have 8 to the power of 2 equals 64. And with these, it's kind of easy to check, did I do this correctly? Because 8 squared is 64, so I know that I set that up the right way. First, last, middle. We've got 12 to the power of 2 equals 144. And the next one, which looks like it again, is the power of 2, about 4 squared equals 16, which is true. And then I just want to take a look at this one over here on 22. You set it up the same way, so 16 to the power of negative 2 is 1 over 256. So don't be scared of those negative exponents or those fractions in there. And then this final section for the review, we're writing each equation in logarithmic form. So it's the same thing, just backwards, but it's still first, last, and middle. So we have log base 15 of 225 equals 2. First, last, middle. Log base 4 of 1 over 16 equals negative 2. And this one. First, last, and middle. Log base 11 of 121 equals 2. So these are the odds for the test review. You are responsible for the evens to make sure that you get this completed and then turned in on Canvas, and then tomorrow will be your test on Canvas as well.